All right, today we're diving into a piece of tech that's a true hidden hero. It's absolutely essential to our modern world, but most people have never even heard of it. We're talking about the ball screw, the unseen engine of precision.
Have you ever just stared at a 3D printer as it works, or maybe seen a video of a factory robot moving with this impossible, superhuman accuracy? It really does feel like magic. So how do they do it? How do they get that perfect, repeatable precision, time after time?
Well, it's not magic. It's physics. And at its heart, it's all about winning a fight against one single, stubborn, invisible force: friction. See, every time you try to turn a spinning motion into a perfectly straight line, friction is right there, ready to steal your energy and mess up your accuracy.
So how do we win that fight? Here's our game plan for today. We're going to look at the precision problem itself. Then we'll meet the ball screw, uncover its secret ingredient, find out why it totally rules, and finally explore the incredible world it helps to build.
Okay, first things first, the precision problem. The big challenge for so many machines is this. How do you take this simple spinning motion from a motor and turn it into flawlessly smooth, straight line movement? For a long time, the standard way to do this was with something called a lead screw. But you've just got threads sliding right against each other, and that creates a ton of friction. The best way to picture it is like trying to drag a really heavy box across a concrete floor. It's tough, it's jerky. But a ball screw, it changes the game by introducing rolling. Now it's like putting that same heavy box on a wheeled dolly. All of a sudden, everything is smooth, easy, and way more efficient.
So, keeping that problem in mind, let's properly introduce the hero of this story, the super elegant solution to that friction problem, the ball screw.
So what is it exactly? Well, a ball screw is a high-efficiency mechanical device, and its whole purpose in life is to translate rotational motion into linear motion. It's designed to do that one job, turning a spin into a straight line, better than pretty much anything else out there. But how does it get that incredible efficiency? Well, the answer is in its secret ingredient. And it's not just about using ball bearings. The real magic is all in the recirculation. Let's follow a single ball bearing to see how this whole thing works. The main screw shaft turns, right? The bearings roll in these special grooves, and that pushes the nut forward with almost no effort. Then, as the nut moves along, the bearings get to the end of their path. And now here's the brilliant part. They pop into a little return channel inside the nut itself. That channel just feeds them right back to the beginning to start the whole trip over again.
And that is the absolute key. This quote just nails it. The genius is not just in using balls to reduce friction, but in creating a closed loop so they never stop working. It's a continuous, never-ending cycle, and that's the secret to its incredibly smooth and efficient motion.
Okay, so this is a really clever design, but it's not just a cool idea on a whiteboard. Let's dig into why ball screws absolutely rule and talk about the real-world advantages you get from all that efficiency.
The headline number here is just staggering. A typical ball screw is over 90% efficient. That means almost every bit of rotational energy you put in comes out as useful linear motion. Almost nothing is wasted as heat from friction. And this chart just puts it in perspective perfectly. You've got the ball screw way up there at 90%, just towering over a traditional lead screw, which, is lucky to hit 40%. We're talking more than double the performance for the exact same amount of energy. It's not even a contest. So what does being 90% efficient actually get you? Well, it means you get extreme precision and accuracy, because there's no jerky friction causing tiny errors. It means you can use a smaller, less powerful motor to get the job done. You can run things at much higher speeds, and with so little friction, there's minimal wear and tear, which means the whole machine lasts a lot longer. It is literally a win on every single level.
And that brings us to our last section, the world they build. Because I promise you, once you know what a ball screw is, you start to realize these amazing devices are hiding in plain sight, powering the technology that's all around us.
Those big CNC mills that carve the parts for your phone? Ball screws. The 3D printer sitting on a desk? Ball screw. The robots in a car factory? You guessed it, ball screws. They're inside airplane flight controls, the beds of MRI and CT scanners that need to be perfectly still, and even in the ultra-precise machines that make the computer chips for, well, everything. So when you boil it all down, it's just such a cool story. It all started with one simple, really elegant idea. Just replace sliding with rolling. And from that simple concept, we get the power to build our entire modern world with a level of precision that would have been pure science fiction just a few generations ago.
It really makes you wonder, doesn't it? The ball screw was a massive leap forward. So the big question we're left with is, what's next? What amazing future technology, what idea that seems impossible right now, is just waiting to be unlocked by the next big leap in precision motion?